This is a live demo of how to set your tool offsets and define the workpiece offsets. We will first demonstrate on how to find the tool offsets for this machine. Before we do anything in the machine, if we're going to be accessing this area in here, we must be sure that we hit the E-stop first. Once the E-stop has been engaged, you can go ahead and lower the protective screen. And then using a pin, you want to go ahead and insert this into the slot here. And then you want to rotate the spindle until the pin locks in and prevents the turret from rotating. Once you have that, you may then grab your reference tool, which will probably be the 9/16, and your Allen wrench, which is about 3/8, and you'll insert it into the cullet below. If you're working by yourself, be sure you have one hand on the tool and slide it into the cullet, but keep holding it with your hand, and with your free hand, go ahead and tighten the draw bolt on top, like so. And for tightening, all you have to do is just place the Allen wrench at like so, and with two fingers on the end, just go ahead and push until it is tightened, and that's all you need to do to tighten the tool in. Once the tool is in, you may now remove the safety pin, bring up the blast shield, and disengage the E-stop. Once we have the tool in the spindle, when you hit the E-stop and disengage it, you'll have to click on the reset. That this is a digital emergency E-stop, so keep in mind you need to disengage that as well. So then once we have the tool in, we first want to go to our configure tool table and make sure this table is propagated with all the tools that we'll be using. So for our reference tool, that will be our tool 1, which, like I said, will be the 9/16. And we just want to make sure we enter the diameter, which is about 0.565 inches, or roughly that. The diameter of the tool may be different. Be sure you use a micrometer or another measuring tool to confirm what the diameter will be. And we'll also be finding the offsets for the 3/8 bit as well. Make sure you also enter the diameter. And for this, for example, we'll just say that the diameter for this tool is about 354. Again, this is just for example. This is not the actual diameter. Once we do that, we want to make sure that the heights for all these tools are 0. After that, we can go ahead and click apply and then click OK. And when we find the tool offsets, we want the spindle motor to be off, so we don't need that running. Then we'll go ahead and go to our settings, our offsets. And then this window here, we want to click and make sure we enter tool 1. And then using our hot arrow keys, we're going to go ahead and move the tool above our place where we'll be finding the 0. In this case, we'll be using a wax block. We will now move the tool roughly above the block. And right there, before we go any further, if you want to make sure that you're using a sheet of paper to help you determine when it touches off. So you'll just have this on top of the block. If you have a partner, you'll ask him to move this back and forth. And once the tool makes contact with the paper and it stops shifting, that will be your 0 point. But if you're working by yourself, try to work best to your ability. In the software, there's just a few more things we need to take care of. Because we're using a sheet of paper to determine where our 0 point is, we need to tell the software how thick that sheet of paper is. So first we want to go to gauge block height, and then we want to enter the thickness of the paper. And for this example, we'll say it's like 0.0032 inches. Then you'll hit enter, and it should propagate into this window. And you want to enter the same value into this window as well. And the last thing to change is because we want to touch the tool against the block, we want to make sure that we don't go too deep. So what we need to do is hit the tab button with this window pop up. Then you want to enter 10% for the jog rate and hit enter. Then go ahead and click the tab button, and that should slow down the rate of the axes. We will now touch off our reference tool to the top of the block. As you can see now, the tool is touching, but the paper is still able to rotate, so we'll move it down a little further. Now, as you can see, the block is now in contact with the tool, and the paper is no longer able to shift around. Now that we have touched down, we can go back to the software and implement the tool offset. Once the tool is touched, we want to make sure we first click Set Z, and this will propagate the data over to here where our Z height is, and then we want to click Set Tool Offset. And as you notice that this value here was a positive, now it's become a 0, and now the system knows that this is our 0 point for our reference tool. Once we figure out our reference tool offset, then we can go ahead and then determine the other offsets for our remaining tools. Once you have made your reference with your reference tool, go ahead and raise the spindle off the block just high enough so you have enough space to remove the tool and insert the next one. And once again, if you're going to be playing around in this area, make sure you hit the E-stop first before you open the blast shield. And once again, in order to change the tool, make sure you insert the safety pin into the collet and make sure it's locked in place, preventing it from rotating. Once again, one hand on the tool, another hand, go ahead and loosen it. Just make sure when you're pulling it out that the tool does not fall off, and so we can help prevent any further damage to the tools, as you just saw right there. Once you have your reference tool out, go ahead and insert your next tool into the spindle. And once again, one hand on the tool and one hand tightens. Again, if you are with a partner, then work together to help each other get the tool secured into the spindle. And once it's secured, go ahead and remove the safety pin, close the blast shield, and disengage your E-stop. Once the tool is in place, go ahead and lower the tool down until it's in contact with the wax block and the paper. Again, make sure to be moving the sheet of paper back and forth. As you can see, it's able to move around, so we need to lower the spindle a little closer to the block. It's still able to move, we'll move it a little down further. And now the tool is in contact. Once the tool has made contact with the block, we then want to go back to our software. And in this window, we want to enter Tool 2. And then just click Set Tool Offset. And as you notice that it transferred whatever value was in this window here to our Z offset and replace it with the height of the thickness of the sheet of paper. And if we went back to Tool 1, it will show us that we are approximately this far down from where we designated our 0 point. Use this to make sure that your tool offsets are accurate and to double check that they're working. Once you are finished, then you want to go ahead and click Reference All Home to move the spindle back to its home position once you have finished all your tool offsets. And this is the same procedure you'll be using for all your tools. Just be careful when you're doing your tool offsets that you don't damage the tool or the measuring device that you are using. So once again, once you find all your references, go ahead and click Reference All Home, and it will move the spindle back to its home position. Once the offsets have been determined for your tools, we can now go ahead and find your workpiece offsets. The way we're going to do this is we're going to be using a edge finding tool. Basically, what this tool is for is that once you get close to the edge, the spindle will be rotating, and this will also be rotating as well. Once it makes contact, it will slightly shift to the side, indicating this is our touching point for this axis. Again, we're going ahead and insert this into the spindle motor. So same procedure, engage the e-stop, lower the blast shield, insert safety pin into spindle. One hand inserts tool, other hand tightens it into spindle. And once it's secured, remove the safety pin, raise the blast shield, disengage the e-stop, and then we want to go ahead and go to the software to determine our spindle rate. Because we are trying to find our workpiece offsets, we want to set our spindle speed for about 500 or 700 RPM. So the way to engage the spindle motor is by, first we need to click in this window and tell it how fast to rotate. For our purpose, we'll say about 500 RPM. Then we hit enter. Then it should propagate up to this window with the same value. And then we want to go ahead and click on the spindle button, and this will engage the spindle motor. Once you click it, there should be a 1 to 2 second delay, and the spindle motor should engage. As you can see, it is starting to rotate at approximately 500 RPM. Once the spindle motor is running, then we want to go ahead and go to our settings tab. My apologies, the offsets tab. And this is probably a good idea before you start on the spindle motor. Go ahead and measure the diameter of the edge finder and then enter into this window. For our purpose, we'll say that it's like 0.05 inches in diameter. And then make sure that we have tool 0 entered in this window here. Once that is set up, go ahead and use your hot arrow keys to adjust the spindle motor until you can find the edge of your axes. So we'll go ahead and first find the 0 point for the x-axis. So we'll go ahead and move the spindle motor to approximately where that will be. Again, once we get close to the edge, we want to go ahead and hit the tab button and adjust our jaw rate to 10%. Hit the tab button again to remove the window, and then we'll go ahead and find our 0 point for the x-axis. And as you see, the spindle has shifted, indicating that we have touched our 0 point for the x-axis, and then in the software we can determine how to enter that in for our data. Once the edge finding tool has touched the edge, and again this is for the x-axis, we want to go ahead and click this select button, and once we click this, the software is then going to take the diameter of the tool and do a little bit of calculations and make the adjustments when we enter the data. So when we enter the data, it's going to take into account of the diameter of our edge finding tool and then subtract that from our actual value that we want for our 0. So if we click select, we will notice that it entered the value into our X window here and has entered the radius of the diameter that we have entered. And then then we will use the same procedure again to determine the 0 point for our Y axis. And then once we're done that, we can then go ahead and click reference all home, and then we can switch out the edge finding tool for our tool 1 or our reference tool. Once you have found the 0 points for your X and Y axis, home the machine. Just make sure you turn off the spindle motor before you home it. You'll have to go back to the program run and turn off the spindle motor before you click reference all home. Once the tool has been home, go ahead and hit the e-stop and replace the edge finding tool with your tool 1 or your reference tool. Again, insert the safety pin, Rotate spindle until it locks into place. One hand on tool, one hand loosens it. And then go ahead and insert your tool 1 or your reference 1. And then again, one hand hold, one hand tightens. Move the safety pin, close the blast shield, and disengage E-stop. Now for this one, you won't have to turn on the spindle motor. You just have to move the tool above the block. And again, use the same method to find where it touches. Just place a sheet of paper on top. And if you have a partner, once again, have them move it back and forth. If you're working by yourself, then do the best you can. Once again, to find our zero point for our workpiece, we again want the sheet moving back and forth until it tells us that it is touching the block. So again, make sure that before you go any further, that you hit the tab button and enter 10% jog speed, and then hit the tab button again to get rid of the window, and then use your hotkeys to determine your Z point. And as you can see, it's now touching, and then all we have to do now is just determine our 0 point for the Z. One thing I failed to mention is that when you're finding the 0 point for your Y-axis, you want to select this button here, and this will determine the 0 point for your Y-axis. Again, this is for your 0 point in your X-axis. If you click this, it's going to do the same math. It's going to enter the radius of the edge finder into your Y window. As for setting your Z, again, we want to enter in the thickness of the paper that we're using. And again, for example, we'll say like it's 0.0032 inches. And we want to hit enter. And then we want to make sure that this window here is showing tool 1. Hit enter. And then once we have that, we want to go ahead and click set Z. And then it will transfer the value over to this window. And now we have found the workpiece offsets. Last thing we need to do is then reference all home. There is a reason why we're doing this, is because this window here called current work offsets should show the opposite values of what we get in these windows here. So this is a good way to verify if the tool offsets and the workpiece offsets have been entered correctly. So if we look here, we have negative 4.372, and in this window here we have positive 4.8720. The reason why it's not exactly the same is because we were taking into account of the diameter of our tool, and that will explain why it's a little bit off. The same thing here for our Y as well. As we can see here for the Z, that it is exactly opposite of each other. We have 22.2332 here and negative 22.2332 here. So keep in mind, the X and Y probably won't be exactly the same because we were using the diameter of the edge finding tool, but just make sure that you incorporate that, and then it should be exactly opposite of each other. Last thing you want to do is then go back to program run, click load G code, find the G code that you want to run, and then click open. Then the G code should load into this window here, and you should get a tool path generation right here as well. And then feel free to click cycle start, and it should run. Thank you for watching.